Hey everyone, it's me, Miss B, and in this video we're looking at the Unit 2, Lesson 8 practice problems from Illustrative Math Geometry. So, as always with this unit, at least here, we are going to justify our thinking as we answer each question and show our work. So for question 1 here, we have Priya buying raisins and almonds to make trail mix. So I'm going to underline and some stuff as I go along. Almonds cost $5.20 per pound. That sounds important. Raisins cost $2.75 per pound. That also sounds important, especially it's math and it's a number. So Priya spent $11.70. And the relationship between pounds of almonds A and raisins R and the total cost is represented by this equation. So, oh yeah, I see those numbers, the 275 and the $5.20, along with the 1170. Those are in my equation. Now, how many pounds of raisins did she buy if she bought the following amounts of almonds? So, if they're saying how many pounds of raisins, this to me sounds like I might want to solve for R so I can find the number of raisins. So I want to solve for raisins. And raisins is R. And that's actually what we're going to do for part D. So we'll get to there in a second. So generally, the way our prices work, at least, is we would multiply by whatever our cost per pound is. And then we would have a total. So I'm going to say for calculating some of this stuff here, I would have to take that total of $11.70 and subtract however much money she spent on almonds. So in this case, she bought 2 pounds, so that $5.20 for the 2 pounds of almonds. And then that's going to give us the amount of money she spent on raisins, but I want to know the number of pounds and not the total price. So I'm going to divide that then by 275, which is the price per pound. And this is what I'm going to evaluate. So if you're using a basic 4-function calculator, you do have to make sure that you follow PEMDAS or that you may group all of this together before dividing by 2.75. I like to use desmos.com/scientific or the Desmos Scientific Calculator because it'll definitely show me what goes in the numerator of my fraction. But I'm not going to show that on here. I will just type in and evaluate. So 1170, we can do a piece at a time actually, 5.20. If I multiply that by 2, I'm really doing 1170. And I'm subtracting the $10.40 that she spent on almonds and then going to divide by 2.75. So do this 1170 minus the $10.40. That's going to give me $1.30. So she spent $1.30. We're going to take that answer and then divide that by 275. And I am not going to write this as a fraction. I'm just going to write it as an actual decimal for pounds of raisins. And so this, I'm going to round to 3 decimal places after, or 3 places after the decimal. So I'm going to say this is 0.473. It was 4727, but that 7 means we rounded up to a 3. And we're just going to keep doing that same process. We're going to identify the only number that's going to change is our number of pounds of almonds that we plug in. So $11.70, we're going to subtract $5.20 for that 1.06 pounds of almonds, and then we'll have to divide it by 275. Now, I'm not going to do this one piece by piece. I am just going to plug it straight into a calculator, but I can show you what that one looks like. So 1.06, just trying to make sure I can remember all of these here. So let's open up. I'm going to use the Desmos graphing or scientific calculator here. So I'm going to use this button over on the right underneath what looks like a little wrench that has an A and B on it. That's going to create a fraction for me. So then I can type my 1170 and I can subtract my $5.20. And I want to say this was multiplied by 1.06 pounds of almonds. And you'll notice I don't have a denominator yet. So over on the right-hand side, there is a little like warning triangle symbol. It's because you can't divide by nothing, or you can't divide by 0. So now we have to put in our 2.75, and this will give me my answer over on the right. I'm going to round just to 3 places after the decimal. So I would round this to 2.250. And the nice thing about this is you can always hit enter and do the same thing again, or you can edit your previous one and just change what you had written in there for your pounds. So I'm going to head back to my homework assignment page and actually write this down, 2.25. Let's go back to my note-taking app. So this is 2.250. And these are pounds of almonds. I should write that down, or pounds of raisins. Sorry, I'm plugging in pounds of almonds. This is pounds of raisins for each one. Okay. So now we're going to plug in 0.64. So I'm still going to write out what I should be doing. 11.70 minus 5.20 times that 0.64. And this whole thing is going to get divided by 2.75. So I'm going to head back to my calculator and just replace the 1.06 with a 0.64. So 0.64. And my answer on the right updates now. So 3.044 is my answer here. So 3.044 pounds of raisins. And if we didn't know the number of pounds of almonds, we can just use A. So this would be 1170 minus 5.20A. And then that would be over 2.75. And that would equal R, which is the pounds of raisins. So that's all you have to do for question 1. It is kind of a lot. I know I just said that's all, like it wasn't a big deal, but that is everything that you have to do for question 1. Hopefully that made enough sense, but I don't want to spend too long on it because this is kind of a long assignment. So I want to make sure I have time to go over everything. Question 2 here, we have a linear equation with 2 variables, 2x plus 4y minus 31 equals 123. They're asking us to solve the equation first for x and then for y. So if they're saying solve the equation for something, this means get that variable by itself. So I'm going to start each of these by just writing out my original equation, 2x plus 4y minus 31 equals 123. And this is the side where they're asking me to show my work to solve for x. So if I'm solving for x, that means I am working on getting this little piece. That's an eraser. I wanted to highlight it. I am working on getting this piece here all by itself. So I'm going to try to move everything else away or undo everything else on this side. So that includes the 2, the positive 4y, and the negative 31. I like to start in reverse order of operations, which means I'm not going to touch the 2 that's being multiplied yet. we're going to do the add and subtract first. And you can do this in whatever order makes sense to you, but I will draw in my equal sign for my equal sign dividing line, I guess, here. I'm going to subtract 31 from both sides, just because I see that 123 and 31 are like terms, meaning they have the same variable, which is no variable at all. So I actually can combine those. So 2x is going to stay, and the 4y is going to stay, but this is now going to be equal to, and then 123, oops, and I made a mistake. I said I'm subtracting it, but it's already negative, so I need to add. I'm adding 31 here on both sides. I am sorry about that. No, I've been doing math for so long, I still make mistakes, and mistakes are okay, as long as we catch them. And I did. So 123 plus 31, this is going to give us 154. So I'm still working on trying to get x by itself. X is still right here. So I'm going to get rid of the 4y now, because I say get rid of, but I'm just going to move it away from that side of the equation. So we're going to subtract 4y and subtract 4y. Now, those will cancel out, and all I'm going to have left is 2x. I'm going to scoot it a little closer so it's not way far away from my dividing line here. But I can't subtract 4y from 154. They're not like terms. They do not have the same variable. One has a y and one has nothing else. So this is just going to be 154 minus 4y. We just write them next to each other. They just get to hang out. They don't get to combine into one thing. The last step we're going to do here is to deal with the 2 that is in front of the x here. And that 2 is being multiplied, so we're going to divide both sides by 2. And what that does is now leave x by itself. And this is my answer for solving for x, is that x is equal to 154 minus 4y all over 2. And that's my equation and the work. We're going to do something really, really similar for the next part, but we're going to solve it for y. So let's write our equation out here so that we can get started. 2x, I believe it was plus 4y minus 31 equals 123. I'm going to put in my barrier line here so I make sure I'm doing the same thing to both sides and not accidentally adding 2 things to one side. And instead of solving for x, we are now solving to get y. So we want to get y by itself. So I now need to move away the 31 and then the 2x before I end up dividing by 4. So I can start with the 31 the same way I did last time. Not the exact same way, because I started by trying to subtract it. But I'm going to start with 31 and add it to both sides in order to just move it to the other side, basically. So what we'll have here is 2x plus 4y. Those still remain. And on the right-hand side, we're going to have, again, that same number. We're doing 123 plus 31. So this is going to be 154. And now, because we're still looking to get y by itself, we have to subtract the 2x instead of the y term. So that's where these are a little bit different. Since here on this side, we're subtracting 4y because I'm trying to get x by itself. On this side, trying to get y by itself, we're going to subtract the 2x term. But the same idea will apply. I'm not going to be able to actually subtract 2x from 154 because they're not like terms. They don't have the same variable. But this will leave us with 4y, and I'm still able to write them next to each other, 154 minus 2x. And if you wrote negative 2x plus 154, that's still fine. You just can't write 2x minus 154. This negative would have to stay with the 2x. Now the last step is going to look slightly different because on the previous one we divided by 2, but our coefficient here is 4. So everything here is going to get divided by 4. And that will give us, for our answer here, that y is equal to 154 minus 2x over 4. So very similar equations, but slightly different. We have minus 2x over 4 and minus 4y over 2. So slightly different there, but still pretty similar, and that's because we're using the same equation. Okay, let's go to question 3. A chef bought $17.01 worth of ribs and chicken. Ribs cost $1.89 per pound, and chicken cost 90 cents per pound. The equation 0.9c plus 1.89r equals 17.01 represents the relationship between the quantities in this situation. Show that each of the following equations is equivalent to 0.9c plus 1.89r equals 17.01. Then explain when it might be helpful to write the equation in these forms. So we want to show that it is equivalent. That's what they're asking us to do. We can either do that by solving and getting the same solution, but we have two variables. So we're going to have to do the other option, which is rearranging this equation to make it into, I would say this original one, but yeah, I guess I can call that the original equation. I want to rearrange the equations they're giving me so it looks just like this one here. They have C and R both on the left-hand side being multiplied with their price equal to a total price. But what they gave us to work with or to start with is C already solved for and R already solved for. So instead of, like in the previous question, starting with an equation and solving for a variable, we're kind of going to work in reverse. We're starting with it solved, and we would be going backwards to get the original equation. So it's good practice to do this both ways. Now I'm going to try to leave the green highlighted part on the screen there. I now want to figure out what am I trying to turn C into, because it does not have a coefficient right now, and I need it to be 0.9C. So in order to do that, I need to multiply, which means I am going to multiply both sides of this equation by 0.9. And on the left, that's just going to give me 0.9c. But on the right-hand side, I actually need to distribute this. So we're going to distribute 0.9 times each of these pieces. I definitely recommend using a calculator for this, even if it's a basic 4-function one. Decimals are not my friend. I much prefer fractions, and I know that might make me weird, but that's okay. I'm not great at doing them in my head. So 18.9 times 0.9 is something I'm going to do in a calculator for sure. And what do you know? That gives me 17.01. That number looks familiar. That's a good sign. Now we're going to do 0.9 times this negative 2.1. 0.9 times a negative 2.1. That gives me minus 1.89 R. So it's looking better. I see numbers that are familiar based on this. 0.9, 1.89, and 17. I have 0.9, 1.89, and 17.01. The only thing that's different here is C is still on the left and R is still on the right. So what I need to do is actually add this negative 1.89. I'm going to add 1.89 R to both sides. And that way, that's going to remove it from the right. They're two different variables, so I'm not going to be able to add them together. So on the left, we're just going to write them next to each other, 0.9c plus 1.89 1.89r, and it's just going to be equal to the 17.01. And I can double check my green highlighted equation, but I'm pretty sure this is exactly what I was looking for. Yes, it is. Now for part B, we're starting with R solved. So we're going to try essentially the same thing. We just need to start with multiplying through. So let's multiply through by what R's coefficient needs to be. And in this case, it looks like it needs to be 1.89. So let's take R and multiply this by 1.89. And then we need to take the entire left-hand side of the equation and multiply it by 1.89 as well. So I'm not going to have a lot of vertical room to do this one, so I might show my next step starting over here. I'm going to zoom out a little bit. So this would leave me with 1.89r equals. And now, if you're going to do this on a four-function calculator, definitely recommend multiplying numerators and dividing by denominators. So I'm going to take that 1.89 and it's going to get multiplied with the negative 10, or I just know my answer is going to be negative, so I'll put my negative here. But that 10 over 21, that's the part I'm going to distribute here first. So we're doing 1.89 times 10 over 21, and then we'll do it times the regular 9. This, I'm going to multiply by 10, and then when I get that answer, I'm going to hit divide by 21. So this gives me negative 0.9, and it still has the c attached to it, so I have to write c. Then I am going to do 1.89 and multiply that by the whole number 9, and that gives me 17.01. Starting to see all my familiar numbers here now, 0.9, 1.89, and 17.01. But we now have to get R and C onto the same side of our equation, which is right here. So I'm going to add 0.9c and add 0.9c on the left. These are not able to combine, so it's just going to be 0.9c plus 1.89r, and that's going to be equal to 17.01. So we've now shown that we could take each of those and rearrange them to make the original equation. Now, why might it be helpful to write the equation in those other forms? I'm going to write a little sentence here, and I'll say it would be helpful. Actually, let me just explain why it would be helpful first, and then I'll write it out. It's going to be helpful to have these solved for one specific variable because I might know everything else. I might know, just looking at A, that one is solved for C, the number of chicken, or the amount of chicken. If I know the amount of ribs, this will easily allow me to calculate how much chicken, instead of plugging it into my original equation, where I would have to move some things around and do some algebra. If I plugged it right in here, I would just be able to simplify the right-hand side and not have to move anything around. I just have to simplify to get an answer. So I'm going to say it would be helpful to write the equations in these forms when we know one variable value and want to find the other. There we go. That's my explanation. it's helpful when we know one of the values of the variables and we want to find the other one. So I feel like the front of this page, this takes a while, but I think we're getting to quicker questions as we continue here. So these ones will definitely go a bit faster. Speaking of which, we're talking about speed on this next question. So for number 4, we have a car that's traveling 180 miles. So that's a distance, 180 miles, and it's at a constant rate. We want to complete the table to show the rate at which the car is traveling if it completed the same distance in each number of hours. So we're still doing that 180 miles, and then we want to write an equation. Well, our rate, this is probably miles per hour, or mph. So a rate being miles per hour means I should probably take my number of miles and divide it by the number of hours. So for us, the number of miles is that 180. So I am going to do 180 and divide it here by 5. That's not going to be my actual answer. I'm actually going to do that on a calculator. 180 divided by 5. And that's going to give me 36. So for this one, we'll have 36. And we're going to continue to do that same thing, 180 divided by 4.5. That's going to give me 40. If we do 180 divided by 3, that should make 60. And then if we do 180 divided by 2.25, that's going to be 80. Now, we want to write an equation that would make it easy to find the rate at which the car was traveling in miles per hour r if it traveled for t hours. So that's just using variables for both instead of giving us a travel time and being able to calculate the other. What you can think of this as, and the way you may have seen it before on some of these assignments, and definitely I know we've had this on some of our tests, is the generalized form, and that would be where we would put here. I'm going to add just another box because mine doesn't have a box for it. Some of yours might. If we had t travel time, how were we finding our rate of travel? And that was miles per hour. So we were taking our miles, which is 180, and we're dividing it by the amount of time. So that's going to be the expression we'll use, but it's not that t is equal to that. Those would just be my table values. But I am going to say that r, or the rate, because that's what this column is the rate of travel. That rate, or r, is equal to 180 divided by t. And if you didn't know already, a distance is equal to rate times time. So if we didn't know the distance, we would have d is equal to r times t, and that would be your basic setup. And you could always plug in then 180 for your distance and then solve for whichever variable you needed. But we don't need to keep that on here. That's just a little extra, if in case you weren't aware. Moving on to number 5, we have bananas cost 50 cents each and apples cost $1. We want to select all combinations of bananas and apples that Elena could buy for exactly $3.50. Now, you could write an equation for this and plug numbers in, but 50 cents and $1 are fairly easy numbers to use, and we don't have numbers that are pretty large here for our bananas or our apples. And Elena's cost is $3.50. So I'm just going to kind of write underneath each one how much it would cost. So bananas is going to cost $1 because they're 50 cents each. So I'm multiplying that 50 cents by the 2. And then this one's going to be $2. So it's not going to be A because that would only cost me $3 altogether if we added it up, and not $3.50. 3 bananas is going to be $1.50. 50 cents, 50 cents, and 50 cents. And then 2 apples, that makes $3.50. So B is an answer. Question or option C, they're saying, what about 1 banana and 2 apples? Well, that would be 50 cents, and 2 apples, that's not going to work out. That's $2.50. 1 banana and 3 apples, 1 banana is still 50 cents. And 3 apples is going to be $3. So that would be $3.50. So that works as well. 5 bananas. Well, they're 50 cents each. So 2 bananas would be $1, which means 4 bananas is $2. So 5 bananas is going to be $2.50, and 2 apples, $1 each, would be $2. That's $4.50. Not going to work. But F works, because 5 bananas we know was $2.50, because we just found that one out, and 1 apple is $1. That makes our $3.50. So this one works as well. So for this question, it's B, D, and F. Let's look at number 6. We have a group of 280 elementary school students and 40 adults. So 280 students, 40 adults. They're going on a field trip and planning to use 2 different types of buses to get to their destination. The first type of bus holds 50 people, and the second type of bus holds 56. Andre says that 3 of the first type of bus and 3 of the second type of bus should hold all of the students going on the field trip. Students and adults going on the field trip. Is Andre correct? And explain your reasoning. So if he had 3 of the first type of bus, that is going to be 50 and 50 and 50, or 3 times 50. And if we had 3 of the second type of bus, that would be 56 people in each one. So 3 times 50, that's 150. And 3 times 56 is 168. So 150, if I combine that with the 168, that makes 318. Now this is seats. That's how many seats those buses would have put together. But I need to know how many people there are. So there's 280 students and there's 40 adults. So we don't have to do anything complicated here. 280 plus 40. And that is 320 people. All right, well, I only have 318 seats and 320 people, so I am going to say Andre is incorrect. And I can say Andre's incorrect because they would need 2 more seats to fit everyone. There we go. That's 1 through 6. We do have a backside of this paper, but after that, there's nothing. So it's 7, 8, and 9. Elena says equations A and B are not equivalent, and then we want to explain why she is correct. So she is correct in saying that these are not correct. So, I think I see what they did. So they just have 5x on the bottom one here. So it looks like they were subtracting 13 and subtracting 13, which if you did that, great, would give you 35. But the important part here is that this -5 needs to remain negative. So she is correct because subtracting 13 from both sides gives us negative 5x equals 35, not a positive 5x equals 35. Basically forgot to keep the negative with her coefficient of her variable. And that's it for question 7. For number 8, to grow properly, each tomato plant needs 1.5 square feet of soil, and each broccoli plant needs 2.25 square feet of soil. This graph shows the different combinations of broccoli and tomato plants in an 18 square foot plot of soil. We want to try to match each point to the statement that describes it. So it's important to note that on the horizontal, we have the number of tomato plants, and on the vertical, we have the number of broccoli plants. So I only see 2 answers that actually land on the graphed line. So I only have 2 things that could be answers or solutions to this, or things that are done appropriately. So that would be the whole amount of the soil being used and not over or under. So point A, let's actually read our descriptions. So the soil is fully used when 6 tomato plants and 4 broccoli plants are planted. I think fully used is going to be C, and that is 6 on the tomato plants and 4 on the broccoli plants. So we're going to match this one here. This one matches with point C. For the second one, only broccoli is planted, but the plot is fully used and they can grow properly. So if we only plant broccoli, that's only on the vertical, meaning we have 0 left to right, and that is going to be A. So A matches up with number 2. Okay, so then we have after 3 tomato plants and 2 broccoli plants were planted, there is still extra space. So let's find 3 and 2 on our graph. And that looks like it's 3 on my horizontal and 2 on my vertical. That should be point B. And if it's underneath, that means we have extra space, because if it landed on the line, that would be all the space being used. So number 3 here is going to match up with point B. Did not mean that to be a curved line. And then the very last one, we're still going to make sure that it works with it, but it should match up with 4 tomato plants and 6 broccoli plants. The plot is overcrowded. So overcrowded means they used too much space. And yeah, 4 tomato plants. I see 4 tomato plants here and 6 broccoli plants here. And it does land over the limit. So they should be using more than 18, was it 18 square feet? Something like that. They're using more, they need to use more space than they actually have. It was, yeah, an 18 square foot plot. So they would need more than 18 square feet to fit those. But everything matches up. And so number 9 is the very last one. This is to select all equations that are equivalent to 3x minus 4 equals 5. So the first thing I like to do is just try to solve this and say, hey, how could I solve? I might add 4 to both sides, and then that would give me 3x equals 9. If I went from there, I could divide both sides by 3 and then get that x is equal to 3. So by solving, as long as we're doing balanced moves, we still create equivalent equations. So 3x equals 9 and x equals 3 are both going to be equivalent to this original one. And look at that. A is 3x equals 9. So I know that one is equivalent. That was a step I took in solving. And then I got that x is equal to 3. I do see one that has x isolated, but that says x is equal to 9. So I'm going to cross that one out because I know that can't be true. Now that I know x is equal to 3, I have a couple options. I can analyze and see what they might have done on each of these ones to see if they work, or I can also take 3 and just plug it in and see if I get something that's balanced. But I like to do the analysis part. I just also like to remind you that you can find a solution if there is, if you're able to, and plug it in to check. So for B, it looks like here they're just showing the work of what I was doing originally, adding 4 to both sides. They just haven't simplified it yet. So since that is a balanced move, meaning they are making sure they're doing the same thing to both sides, that one is equivalent. X minus 4 equals 2. So they left the minus 4 part alone, but it looks like they tried to subtract 3 from both sides. If I subtracted 3, 3 and 3x are not like terms, so we can't actually subtract there. So C is going to be incorrect. And then let's check E, because that's our last option. Negative 4 equals 5 minus 3x. So I had 5, positive 5 on the right-hand side, and we still have positive 5 here. It looks like they're subtracting 3x from both sides. And they are correct that you would leave the negative sign with the 4. So E is also correct. I'm going to write real quickly what they did on each of these. So I know that 3x equals 9. We got that by plus 4 to both sides. And that was also the same for B. They just didn't combine anything here, but they added plus 4 to both sides. The other two don't work, but this one is subtracting 3x from both sides. And that is it. So thank you for sticking with me through this rather long video, but yeah, this has been the Unit 2, Lesson 8 practice problems for Illustrative Math, Algebra 1.